start.
So good afternoon, everybody, to yet another session under the Storage and Handling Knowledge series. Uh, this is our 18th session, and we have been doing this engagement with all our audience since more than a year now. And we have been very sort of fortunate to be able to continuously get engagement from all of you who have been coming on this platform and going through the knowledge that we have been sharing on this platform across various topics in the intralogistics domain, whether it is about different types of equipment, different types of accessories, different variety of applications, safety practices. So initially, when we started, it was us who were trying to share our knowledge and expertise with all of you. As we moved along, we started sort of inviting guests who would come on this platform and share their knowledge. We have got people coming in for talking about batteries, chargers, controllers, order pickers. So basically, this has become a very thriving community where we have always made sure that we keep this platform for pure knowledge sharing, which is like a value add to all of you, because there are many things where we keep sort of going through using an equipment, but not really understanding the nuances behind that. And small things which can impact a lot. Sometimes they are not really known to the people because they are from a different domain. So this platform is just a small attempt to clear those nuances, and so that we are able to add value to the day-to-day operations that people generally go through, and they're able to get more out of their equipment, out of their storage spaces, and basically increase their productivity. Now, in that sequence, today we have our session on the transmission system, which is the heart of the diesel forklift. Now, let me share a small sort of trivia around this particular product category, that diesel forklifts, even though we are talking about world going towards greener technologies, which we are anyways seeing across various sectors, still, as we speak today, diesel forklifts remain the highest numbers being sold in India in the different category of products. Though, of course, the share of diesel forklift is slowly coming down because, as I said, because of the environmental considerations, but still due to its sheer versatility, its sort of usage in multiple applications. This is one product which sort of is finding usage, still finding usage in many applications, whether you go for heavy applications in steel industries or ports, or we go for furnace applications. So all these places we still find these products being used extensively. So when we discussed internally, the thought came in that one of the products which is having such extensive usage, why not talk about the core part of that particular equipment, and we share that knowledge with our audience, so that if they are able to take care of that core part, or they are able to understand that better, they will be able to get more out of their forklifts. And because, as I said, forklifts is still the biggest sort of number in terms of the market size, I think this is one topic that is going to impact or help a large number of people. So, to talk on this important topic, we could not think of anybody else. I mean, the first and the only choice that we had was Mr. Deepak Vijaykar. And we are very, very grateful to Mr. Vijayakar for accepting our invitation to be a part of this particular event. And as I said, we could not have got anybody better than him to talk on this topic. So his credentials are quite huge. So I'll try to make it a bit brief in the interest of time, because obviously you would not like to hear me much as you would like to hear Mr. Vijayakar. So, Mr. Vijayakar is a mechanical engineer with a specialization in automobile engineering. He excelled as the head of design in Godrej Material Handling, where he has worked for 30 years. I mean, that's the level of experience that he is bringing on the table when he is talking to all of us. And during his tenure, he introduced a variety of material handling models, which included both the diesel and electrical forklifts, the empty container handlers, and even warehouse trucks. Like he was among the flag bearers of introducing this particular product category in our range. You ask, we design is the common adage that is associated with Mr. Vijayakar, and that goes on to show his sort of attitude of accepting any design challenge that is thrown at him, and not only accepting it but executing it to perfection. So, and over the years, he has kept on building his knowledge base through his visits to international exhibitions, talking to various partners, and he is continuously being upgrading his knowledge to make sure that whatever he delivers to the organization that he is working for is with the contemporary technology. So, without taking much of your time, I would now like to invite Mr. Vijayakar to take us through this very enriching session. And I'm, of course, very keen to listen from him about the heart of the diesel forklift, which is the transmission system. Over to you, Vijayakar, sir.
Good afternoon. I wish to extend a on the transmission system, the heart of the forklift truck. I also wish to thank Abhishek Chaturvedi for having invited me for doing this seminar. It is true that I've had a long innings with Godrej, and all of it has been with material handling division. I've experienced with various aspects of manufacturing. Also, I was head of the design department for more than 30 years, and during which period I have been privileged to see introduction of many new products both in diesel and electric range. My presentation will cover contemporary transmission systems used on Indian forklifts with special focus on automatic transmissions. It will start with a broad anatomy of the forklift so that you know where the driveline or the transmission sits into the forklift truck. So we start with the broad anatomy of the forklift. Then in that, what is the role of the driveline? Then we come to the evolution of the transmission of forklift. Then we have two major offerings in the diesel forklifts here in India. So I am going to have some little introductions to two types of transmissions, the FC coupling transmission and automatic transmission coupling, automatic transmission type forklifts, how they are set in the Indian market, Indian field. Also, I will speak in details about the Powersheet Gearbox, which is so special to the automatic transmission. So the agenda, I've just spoken to you, some parts I've already spoken about. Then the few last points are the diagnosing, testing, care and maintenance of the automatic transmission. And finally, I have a small brief comparison of the FC forklift, that is the fluid coupling forklift truck with the automatic transmission truck. So this is the agenda, and now I'll start my presentation. The transmission makes its position in the forklift in the drive line. So first let's look at the buildup of the forklift. The buildup of the forklift is made up of first the important aggregates of the diesel forklift are the driveline system, then the lift and tilt system, the steering system, and the driver's module. The driveline system is the one which takes care of the horizontal motion and the gradient motion of the forklift truck. So this is where the transmission takes its position. The lift and tilt mechanism, which includes hydraulics, is the portion which is used, which takes care of the lifting, tilting systems, includes the mast, the tilting arrangement, and also the hydraulics related to those activities. The third is the steering system, which includes steering mechanism plus the related hydraulics. And finally, the driver's module, which includes all the items which are related to controls for the operator, like for example, the accelerator, the brakes, the lift and tilt controls, the forward, reverse, and high-low controls, and parking brake. All these controls are there, and the operator sits in around it, and how it's ergonomically made available to him, and also the safety like the overhead guard and other things which also are contributing to the safety of the operator. The ergonomics and safety also included here. Now we will delve in the driveline system, because now we are talking about the transmission. So now let's look at what is the driveline including. The driveline system includes the following items: the engine, the transmission, and the axle. The engine is the power unit or source of power. Now the engine is not just taking care of the horizontal motion and the gradient, it also takes care of the lifting and tilting arrangement, because there is a hydraulic power which is taking help of the engine. Then it also it helps in the steering system, but it also helps the power as a power unit for the transmission system also. So in the driveline, power unit, engine is one of the important aggregate. Next item is the transmission. The job of the transmission is the interface which gives connection and disconnection of drive, provides for reversal, provides for a level road running and climbing gradients. This transmission part is the one which we are actually focusing. Then the drive axle. Drive axle is also not a small item, it's a very major item of the forklift truck, because number A, it has the capability of giving a fixed speed reduction. Why that speed reduction required? Because the engine is running at 2300 or 2000 RPM, but the wheels have to run only at 160, 175 RPM. So there's a huge drop required. So continuous drop is required for the speed, and this drive axle gives that function. It also does a major job of taking the maximum weight of the vehicle when it's loaded. Just to give an example, a forklift truck of a 3-ton capacity would say weigh about 4,500 kg, but when the load of 3 ton is kept on that forklift, then the total weight would be say 4,500 plus 3 ton, so that will be 7,500. But in that case, can you imagine what is the front axle load? It will be something like 6,500 or 6,700 kg, which means it takes bulk, or say 70% of the load of the full weight of the forklift that will be coming on the drive axle. Then now we come to the evolution of the transmission systems. Uh, Transmission systems um, have evolved over a period actually. If you see just post the World War II, the forklifts were used in a big quantity, and in those days um, there was a jerky motion, and as I mentioned earlier, that um, when you are at the uh, when the forks are lifted for stacking, say 5 meters, or then in that case there would be a problem of instability and swaying of the mast. So then came the blessing in the form of the fluid coupling. The fluid coupling has a major advantage of disconnecting the drive between engine and transmission, and then have the facility of accelerating and getting the smooth motion in the forward direction. So, so dry clutch is still there because it has to disconnect the gearbox from the engine, um, because for doing a constant mesh sliding of the sleeves or sliding of the gears, it was necessary that um, the input shaft of the or the engine input has to be completely disconnected. So fluid coupling gave the advantage that once the clutch was released completely, still the truck will not move until the fluid drive gives the drive to the turbine, and this way you got a very smooth type of movement, even even during the stacking stage. It eliminated the above limitations and also the dry clutch. But here, it is necessary to inform that the dry clutch could not be eliminated because of the necessity of completely disengaging drive for doing the engagement of the clashing gears or the sliding mesh or the constant mesh arrangement. Now came the very important invention of the last century, that is the torque converter. The torque converter has many added features. One is that it's able to give the similar smooth movement of the forklift. It also gives that same similar advantage for stacking when we have to move smoothly forward. That also is available. In addition, it gives you a multiplication of torque, especially when it's needed. That is when you have to overcome the static inertia. What is static inertia? That is, your truck is standing at the standstill position and you are first applying your engine torque. At that time, the resistance due to the static inertia creates a situation of multiplication of torque, and which the torque converter gives. So this is a major advantage with the torque converter. And this comes along with another great invention, and that was the Powersheet Gearbox. This Powersheet Gearbox, you'll soon see how it's constructed. It does not have clashing gears. All gears are in constant mesh, similar to a constant mesh gearbox. But in the constant mesh gearbox, you have to move the sleeves over the dogs, and that requires a lot of effort. Whereas in the Powersheet Gearbox, you will find that the gears are in mesh and the gears are engaged with the hydraulic power. That's why it's called Powersheet Gearbox. So they have a torque converter, a wonderful invention. Then you have got a multiplication arrangement, and then you have got operator satisfaction due to very quick response while changing direction. Now we come to the two major buildups of transmission which we have in India. First is a buildup of fluid coupling type of transmission. So major aggregates in that are the fluid coupling, which gives a hydraulic coupling between the engine and gearbox in addition to the dry clutch. Okay, so it's an additional item which gives that smooth drive. The gear, the clutch is still there. It facilitates movement, especially with mast elevated. That's a major advantage having introduced the fluid coupling. The dry clutch, manual clutch is necessary because we have to completely disconnect the drive between the engine and the gearbox, and that the fluid coupling cannot do. For the sliding mesh gearbox, I want to add here that in the 70s there used to be BST buses with epicyclic gearboxes, or they were called pneumocyclic gearbox. Those epicyclic and pneumocyclic gearboxes were using fluid coupling only to disconnect the drive. So it is possible that in this stage where the fluid coupling was invented, some type of gearboxes could be used along with fluid coupling without having to use the clutch. This is just a sharing of information. Then you have the third aggregate, that is a 2-speed sliding or constant gearbox. Some of our reputed manufacturers of forklifts here are using sliding mesh gearboxes earlier, and they were working on the constant mesh gearboxes also. The final drive uses the crown pinion reduction. They use a single crown pinion reduction. This is a build-up of the fluid coupling type of transmission. Now we are looking at the automatic transmission, which is our focus today. The major aggregates of automatic transmission are the torque converter, which I just mentioned. It engages and disengages drive. It more importantly multiplies the engine torque up to 2 times that on demand for overcoming the static inertia. So it performs the multiplication of torque only when it's necessary. The moment the need goes, the multiplication goes down and tapers to 1:1. So this is the best part of it. That you are not logged on to a continuous reduction of gear, which would cause a lot of overheating and such type of problems. So it's got a very important quality of multiplying the torque when it's required. And the second last thing, it facilitates the smooth drive, which is similar to the fluid coupling. Then we have the Powersheet Gearbox. It's another wonderful item which is used for the automatic transmission. So it facilitates changing of the direction of motion, and it facilitates changing of speeds in the 2-speed transaxle. Sometimes even single-speed type of transaxles are available. So these are the build-ups of two types of transmission which are being used in India. First one was the fluid coupling type, and the other one is the automatic transmission. The final reduction is in the form of double reduction. Here, most of the automatic transmission trucks or transmissions manufactured here and abroad have double reduction. Double reduction in the form of crown pinion and either hub reduction or an internal gear reduction. Double reduction has one advantage, that if you use a smaller crown pinion, then you could have a good ground clearance. And in one of our Indian forklifts, which is made by Godrej, we have a double speed reduction with the internal ring gear. Now here there is a feature called a pre-reduction brake, which is a good advantage because it is placed between the crown pinion reduction and the internal ring gear reduction, and thereby because it gets the advantage of the internal gear reduction, the brakes are maintained at a smaller size, and because the brakes efforts are multiplied by the last reduction, that is the internal gear reduction. Here you can see a good picture of the transaxles or the fluid coupling type, the fluid coupling plus sliding gearbox, and on the left side, and on the right side you see the automatic transmission with the torque converter is not seen here. It comes in this area. Please follow the arrow. And this is the transmission. This is the Powersheet Gearbox. Now we come to an interesting part, which we just mentioned, which made the major difference to the trucks and the major difference to the transmission system. That is the fluid coupling and the torque converter. So, though our discussion is mainly on the automatic transmission, it's necessary to know how the fluid coupling worked and how the torque converter evolved through it. So let's look at the fluid coupling first. I try to draw attention to the left side figure where we see two fans. One fan, the blue color, is connected with the electric supply, and the other one, the white one, which is in front of it, but it's not connected to the electric supply. So now they're actually placed in front of each other, say about 4-5 inches away, and we start the first fan, that is the blue fan. What would happen is that the fan would throw out a draft, and it will have a draft in of air, which would put a thrust in the actual direction also, but also it would rotate the air mass in the rotating direction also. So the that rotation, which is total draft that is thrown onto the second fan, will cause the second fan to also rotate. So that's what you'll see. If you start this fan, after some time, the second fan, after the first fan gathers a certain speed, it will start rotating the second fan, which shows that a medium like air can be used by one rotating member to cause great influence on the other, to cause rotation with almost similar power being transferred. Now we shift our view to the next one, that is here. This is the basic construction of the fluid coupling. The outer case, it's in the shape of what we call torus, or to make a familiar mention, it looks like a donut, a big donut, and this outer blue chamber has got radial veins integral with it. These blue veins we are seeing, they are straight radial veins integral with it. So if this outer mass rotates, the outer chamber or the donut rotates, this veins also will rotate. Inside this chamber, there's another item called the turbine, which is white in color, which is free of this item. It's on bearings, and it's got its own shaft here. Now, if this rotates, if this blue rotates, blue part rotates, this will not rotate because it's free. Now, this whole this impeller and turbine, now within this closed unit, and inside we put oil inside. Suppose the impeller is rotated, then this radial veins also will start rotating, the blue ones, and the oil inside will be churned and thrown towards the periphery because of rotation, because of centrifugal force. Oil will be thrown towards the periphery, and then because of the direction of the veins and because it has nowhere to go, that thrown oil will tend to go, to the turbine, and it will come down, slip down, and go back inside this. This can be seen better here in this figure because on this side, this figure, the impeller is on the right side, and you can see the donut shape here, and you can see these veins are kept here. When the oil is thrown to the periphery, it will come down, go up towards the turbine, come down, and again try to go to the impeller. And this whole mass, it's stationary because right now it has been held up by a load. So the oil will come, impeller will go up, the oil will go through the impeller to the turbine, come down until it creates kinetic energy such that it can create a thrust on it, and also it has got an angular type of motion. So the oil has got a rotary motion in the form of this vortex, as well as angular motion because of its rotation, and that total effect, a resultant effect, causes this part, that is the turbine, to rotate. The turbine is here, and in here it's on this side. So this turbine starts rotating. So this way, as at some point of time, the turbine will try to come to the speed of the impeller. So this way, the fluid coupling is used as a sort of a drive, so that the impeller, if it's connected to the engine and the turbine is connected through the shaft to the transmission, the turbine will start getting the torque and speed of the impeller. But in this design, the maximum torque which can get transmitted to the turbine is equal to the engine torque. It can never exceed the engine torque or the impeller torque. So this is a design of the fluid coupling, but it gives a good drive, smooth drive. So if it is connected further of it, if you have a clutch and you disconnect the drive and then change the gear, then by accelerating the engine a little bit, then this turbine will get drive, and that drive will be smooth. This is the smooth drive we talked about, which was the major change for the fluid coupling type gearbox. The two vane members, the impeller and driven turbine, straight vanes on the impeller and turbines, and the impeller torque equals to the turbine torque. Now we come to the best invention of the last century, that is the torque converter. This torque converter was designed by a person named a German engineer called Hermann Fottinger. This design came around 1905 and was first used on Chrysler cars, and patents given to a number of auto vehicles. Must have followed somewhat later in the forklifts. Now, the construction of the torque converter has certain changes. For example, here you can see the impeller, you can see the turbine. The parts look similar, but the vanes which are here shown here, they are curved in shape, and the vanes, and there is a third member called the stator. So we have two differences. We have got curved vanes for the impeller and turbine, but here a third member which is called a stator, which is completely in a stock condition, stationary condition in one direction, and it has got a one-way clutch which allows it to rotate in the other direction. So let's look at how it works. Oil will be in this area, that is, it will be filled up about 60 to 70% in this chamber, So when the impeller is made to run because the engine is started, the oil will be thrown. But before that, I want to mention here that we have to consider the static inertia situation where this turbine is connected to the gearbox of the forklift, for example, and the gearbox is then connected to the um, final reduction, and the final reduction has got wheels, and the wheels are on ground, and the mast has got load on the forks. Okay, now that means that the wheels are stationary and rock still, with load on it, and they are refusing to move, which means even this turbine is refusing to move because of the load experienced by the gearbox downstream up to the wheels. What will cause it to rotate? If you start running the engine and the impeller rotates, oil will come down. Now the curved vanes of the turbine is redirecting, is going downwards, and when it comes into this area, it is redirected to the impeller in such a way that it aids its rotation. Not only that, when it goes here also, it aids the rotation. That means this stator is designed in such a way that it redirects all the kinetic energy which otherwise would have been wasted in the form of heat, because this item is refusing to move. It's now sending that kinetic energy back here. So the bulk of that energy mass is now used to multiply torque by mainly because of this stator. So this torque can go as high as 2 to 2.5 times the impeller torque. So let's assume, like, you cannot create energy, right? But you have this turbine at almost 0 point. So you want it to rotate only 1 RPM or 2 RPM. So that now we are creating a situation of multiplication of torque. Say if that at that point engine torque is 5 kgm, then there will be 10 kgm coming on the impeller on the turbine, and that is what can rotate the turbine with that extra torque, that is, say, 10 kilometer torque, which will start rotating the wheels. Once the wheels start rotating, then the turbine does not require that much torque. So slowly the multiplication drops down, and then the speed of the impeller and the turbine almost approach the same levels. This is the beauty of this type of unit, that is a torque converter. So let's just summarize. It has got curved vanes, set an additional component called stator. The stator helps throw back the oil and kinetic energy from the stator to the impeller once again, and because of the curved vanes, which have the same direction as the rotation, I mean aiding the rotation type of arrangement, it goes back, and due to that static inertia situation, it's able to build up the torque. Once the turbine starts moving, the torque multiplication goes down, because the requirement of torque multiplication goes down, the multiplication goes down, and then the turbine starts moving faster and faster until it reaches the speed of 1:1. To get a better idea of how the stator acts really, how the stator is designed, and how the vanes are designed in curved fashion, we go to the next slide. Here is a beautiful figure of how the vane items are helping build up that the inertia torque. So you can see the gray one is the impeller, blue is the turbine, and yellow is the stator. So we start from this point, gray side, and oil is thrown due to the vortex to the top, that is the periphery, and it drops down the turbine, creating force on the turbine, but it is at standstill, rock still position because of the wheels being loaded. So it comes back, but the stator now is directing it backwards in the direction such that it aids the impeller. Beautiful demonstration here. You can see the stator hitting back and throwing back all the oil which came down from the turbine to the stator, back to the impeller and back to the turbine. So loss of energy is not taking place. In fact, we are multiplying the torque. The whole quantum of, or you can say the mass of oil is doing this job of building up the torque, but at a lower speed. And that is what you want. You want to break the inertia. So this is what the torque converter does. So here it's a graphical representation of showing how the torque multiplication is the highest when the turbine speed is 0. That is, it's just about to start and it's building up maximum torque multiplication. And the moment the turbine speed starts increasing, it starts approaching the impeller speed, the torque multiplication goes down, and then it almost goes to the 1-to-1 point of the torque of the impeller. So it goes to the impeller torque level, 1-to-1. So it's a representation of how the torque multiplication starts going down with the impeller speed going up. Now we come to the next interesting part, and that is the Powersheet gearbox used in automatic transmission. So the gearbox used on fluid coupling is a simple gearbox which is used on any type of vehicle. It can be a constant mesh gearbox, sliding mesh gearbox, which is commonly seen in any vehicle. So we are not going to demonstrate how it works because it's a common knowledge. But the Powersheet gearbox is being shown now to understand how it is helping in reducing the efforts for operating for shifting the gears, and how clutch can also be completely eliminated. Let's see. This is the Powersheet gearbox. On the left side, you see the torque converter. The output of the torque converter is the input shaft for the transmission. So this is the transmission input shaft. Just to introduce the other shafts, this is the intermediate shaft, and this is the output shaft. The drive will come from the input shaft to the output shaft. So you have the forward and selector drums rigid with the shaft. Now we have these drums here. They are called selector drums. So the main body has got splines inside, and the splines are engaged with this outer body, which means when this input shaft rotates, this outer body, which is the selector drum, can rotate. But this is just not ordinary, it's not just an ordinary drum. It's got two clutch packs inside. This clutch pack is designed to make these gears, which are free on the shaft, rigid with them. Just to mention, this is a high-low selector drum which is rigid with this shaft, and this is forward reverse selector drum rigid with this shaft, input shaft. Then we have forward reverse low and high. High and low gears are free on the shaft. They are free on the shaft, and they in normal circumstances they are rotating free on the shaft. Only when the clutch is engaged, this shaft can become rigid with the shaft. The gear can become rigid with the shaft. These intermediate gears are rigid with the shaft, and this is a reverse idler pin, which is again free here. So now suppose we want to have a drive coming from for getting the forward high gear. So this is the forward gear. This forward gear is right now free, but if forward gear is engaged, that means at the lever, you select the forward lever. This clutch pack will make this drum rigid with this gear. So this drum being already rigid with the shaft, the gear also becomes rigid with the shaft. So the drive now comes from the input shaft to this gear. From this gear, it will go to this intermediate gear. Now, in this gearbox, there is no position for neutral for the high and low. So this gear is either in high or in the low. So the moment you start the engine, if the engine is started, if you are already in the high position, this gear will be already in engagement with the shaft. So if you have selected forward, then from this gear, from the shaft, first input shaft will energize, this clutch pack will be energized, and the shaft becomes rigid with the forward gear. The forward gear will then drive the intermediate gear, and the intermediate will then drive the high gear, and the high gear will drive this output shaft. So here you can see that the on the top shaft, the input shaft drives the forward gear, whereas here the high gear drives the output shaft. Their functions are interchanged. That means the clutch, if it is engaged on the output shaft, the gear will drive the shaft, and on the input shaft, the shaft will drive the gear. So this is the arrangement. Basically, by having hydraulic clutches doing this job, makes it easy for changing of the speed or changing of gear, no requirement of a clutch. Major difference between the FC coupling and gearbox and Powersheet gearbox. So here I've just mentioned here that input shaft drives the forward reverse gear. The input shaft drives the forward and reverse gears depending on what is selected. And then on the output shaft, high-low gears drive the output shaft. Basically, the important part here is the selector pack arrangement on this drum. There's a clutch. There are clutches here. We'll try to explain the design of the clutch in the next slide. So here, for Porsche gearbox is engaged hydraulically, and there's no mechanical meshing. There's a small description, photograph which shows the construction of this gear, which we call it low gear, high gear, or forward gear. It has got gear teeth plus splines here. These splines are in mesh with the phosphor disc, and there's a steel disc which has got 4 tanks which are rigid with this drum, so that this steel disc rotate with the drum, but this phosphor disc don't rotate because they are just freely placed between the steel disc. So they form a clutch. There's a piston behind this, which when operated makes the clutch disc and steel disc, phosphor disc and steel disc rigid into one mass, and that is the way this drum makes this gear rigid with it. Otherwise, this gear would be running on bearings on the shaft. This is to show how the arrangement of the bearing is there on the shaft. This bearing it makes it free on the shaft, and this item is a bearing race. So it has got internal splines and the ground surface on top on which the bearing is rotating freely. So this is just giving a sort of a support to this needle bearings. And here you can see clearly the splines portion where the phosphor bond discs are sliding. Usually a gap of about 0.25 mm kept between in the phosphor bond, that clutch pack. That means the steel disc and the pack of steel disc, and all. You put a filler gauge and see that there's a 0.25 gap, overall gap, which says that if the clutch is not engaged, then this gear will be free on the shaft. A better sectional view of the clutch pack is seen here. You can see the two gears here. This is the forward gear, this is the reverse gear, and here you can see clearly the piston in the clutch pack, and you can see the steel disc and the phosphor bond disc in between. So you can see steel disc slightly longer because they are now rigid with the drum, and the phosphor bond disc are in between and they are rigid with the gear through the splines. So when the clutch pack engages, or rather moves forward, the whole mass becomes rigid, and that's how the drive from the drum goes to the gear. So this, if you choose the forward, means this forward becomes rigid with the shaft. If you choose reverse, means the this clutch is engaged and it will cause this gear to be rigid with the shaft. Here we are showing you the hydraulics which is used for doing this engagement of clutch and for the Powersheet gearbox. It has also certain hydraulic controls which we'll try to quickly look at. Just to explain the hydraulic basic system, it's got the transmission case itself is a oil tank. Then it's got a suction line, a pump, and the outlet of the pump is going through the filter. And at this point, please follow my arrow. At this point, the oil branches out 2 points. Here it goes towards the pack. Here it goes towards the line for the torque converter. When the speed of the engine is very low, the oil will try to go only from the orifice here. It will try to build up pressure here in the high, as I mentioned earlier. It is either in the high or on the low. Here we have shown the red line which is connected to the low pack here. So you can see the piston here, and oil has already created pressure on this and acting against this. So these are all hydrostatic situations. I mean, oil is going against this piston and stopping, and there is no escape for that oil. So it is creating a pressure here. At the same time, the oil goes up there, and here I am showing a condition where this spool is completely pulled out and it's into the third slot here in the ball, and the oil is going there, here, and operating against the piston here, causing this piston to operate the pack. That means the forward gear pack is engaged. So this is how the oil has gone through the forward reverse spool to this point, and to the high-low spool to the high point. Okay, so you can see this red part is the piston which is actuated and energized. Uh, this part is the forward reverse spool, and this is the high-low spool. Now there are two more arrangements here. Let's look at this arrangement. Now the oil which was going through the top converter is through the orifice is directed into the top converter, goes into the cooler. From the cooler it goes further. The cooled oil is made to go from the other side of this input shaft, not the pack type of the pack routing, but the other side of the input shaft, and they go for cooling the forward and reverse packs. So the low pressure line which is coming out from the top converter after cooling goes and keeps on cooling this pack. So this is the completion of the oil circuit. Okay. However, it's very important to note that the pack pressures are around 160 psi, or you can say 12 bar or close to 12 bar, and that's why we need a high pressure here. Forward and reverse pressures have to be high and much more than the top converter pressure, whatever oil goes into that. So there is an arrangement of a pressure reducing valve here. This is a very good concept which I'll just try to explain. Now this spool you see actually is a spring loaded spool here, spring here. This spool is normally closing this line which goes to this line, the blue line. This line is open, but this is through an orifice. But this side, when these two packs are engaged, the pressure builds up to say 160 psi. Then only, or maybe a slightly lower pressure, this spool is actually there is a small sensor here in the spool. There is a small hole in the spool which keeps on creating pressure here. Only when the pressures on this side, red side, have increased beyond a certain point, this pressure, the sensing pressure, is able to overcome the spring pressure and open the line to the blue hydraulics. So it is always because of this relation of a differential pressure here, we'll always have high pressure on this side and low pressure maintained this side. But this low pressure also needs to be regulated. So there is a small regulatory valve of say 70 psi. So we have a controlled a pressure which is using a pressure reducing valve here. 160, 150 psi is maintained here. Of course, when there's a wear and packs and all that, the pressures would go down a little bit, but otherwise it will be around that. And whatever extra pressure after overcooling the spring pressure will go to this top converter line, and then further getting cooled here. Your further attention is being drawn here. Your next question would be, who's cooling these packs? Forward reverse packs are cooled, but what about the high-low packs? So you can see, first of all, I have to inform you that the frequency of changing direction, forward to reverse, keeps on happening very, very often. So often that the clutch packs are used more often. As compared to that, in the high gear, truck would be operating in high gear for a long time. Maybe the whole day also he might go in high pack. Maybe some time he might encounter a gradient or something, then he'll put in low. So it is very necessary. It's not necessary to have a sort of a elaborate cooling system for the high-low packs. So what they have done is this red line is further, extended further, and through a small orifice it gives oil to the pack, to other pack. Suppose high pack is engaged, that line is cooling the low pack. Similarly, if low pack is engaged, it will cool the high pack. So this type of arrangement is kept here for cooling the high and low pack. It's not exactly the same as the forward reverse. Now we see a small arrangement here. It's called the inching control. Basically, I'll be very shortly mentioning this, what it is. It is basically a device by which it is possible to uh, cause a controlled slippage of the packs of the forward or reverse pack, whichever is the engagement, if you need to reduce the traveling speed in a controlled manner. So, so when you have an external arrangement of applying oil pressure, like using a brake oil to operate this seal, then this plunger, for example, this plunger will be pushing this push rod further, relieving the, rather it will cause this spring to be compressed completely. So whatever was holding this spool has stopped holding it, and whatever pressure is acting on the spool and starts moving the spool towards the left, and thereby causing a restriction to the oil going towards the forward reverse pack, whichever is in engagement. So I have explained to you the forward reverse spool, um, the high-low spool, the pressure regulator valve, and also um, the inching mechanism. Important areas for checking, for ensuring cleanliness and maintaining of the preventive maintenance schedule has to be mentioned here, because this oil, you see, has to be replaced in the way it is mentioned in the preventive maintenance schedule, and the filter also has to be replaced. Because you can see the elaborate system you can use for this Powersheet gearbox. What we showed you earlier was schematic diagram. You saw that the forward, reverse, low packs were there. So there is a control cover on this transmission, on the transmission gear bottom Powersheet gearbox, where there is a provision for of a tapping for checking pressures at forward, reverse, low, high. So at various times during the life of the forklift, if you have some uh, non-functioning or malfunctioning, then we need to find out where the pressures are low, or so there are points for knowing where you can put your pressure gauge and know the condition. And there's also the line, as I mentioned you, the 70 psi pressure of torque monitor also can be checked here. Here you can also show you the forward reverse spool, then high-low spool, and what you see is a neutral switch. So I'll just mention here what's the function of the neutral switch. The neutral switch is a safety device given so that if the forklift is left by the operator by inadvertently, then what would happen if another operator who doesn't know about it just starts he'll just uh, release the handbrake, but when he starts it'll just start moving. So to avoid that, this switch ensures that only if the spool is in the neutral position, this switch will give continuity to the starting circuit. So your starting circuit is connected to your ignition switch and starting key. So if it's in neutral, there is continuity here. If it is in gear, then mechanically and electrically the 2 points are separated. That means there's no continuity. So he is not able to start. So if he's not able to start, he'll bring back to neutral and start. Now we come to another point where people who have been using the forklift would like to know certain things about the use of the forklift and its behavior. Possible problems which can arise on transmission after long use. Jerky or no motion in specific direction. For example, the truck can move in forward, but it does not move in reverse at all. Whether it's in low or high gear, it's not moving. So cause of that could be failure of one of the packs, that is forward or reverse, whichever direction is not moving. Jerky or no motion in a specific speed, that means it is moving in forward and reverse, but only in high gear, not in low gear. So it means that the low pack is having a defect. Then another condition would be jerky motion in all direction, in all speeds. This could be because of maybe the converter pump, that is the converter pump which gives the oil pressure to the packs and also the top converter. So it has already worn out, and that's why in all gears you are finding problems. So that would be apparent on if you put a gauge on the converter pressure. A converter pressure port will know whether the pressure is high enough or not. Now we come to the very you see you can say queer type of problem where it can be really puzzling because motion is available on all directions but very sluggish. You raise the engine but still you're not getting a proper speed. The feeling that general power is missing, something is wrong but not able to diagnose. Maybe sometimes you get proper pressure also, but still you're not getting pressures on forward, reverse, low, high. Are not so bad. I mean, they are not bad to have this type of condition, but you are feeling that there's loss of power, not feeling good about the truck. Something gives a sense of less power. So this is very difficult to diagnose. So here is a very important test which I am recommending. That is a stall test. Now, what is a stall test? Here I am just showing that for knowing the earlier established problems like it not moving in forward, not moving in reverse, or not moving only in low, or not moving only in high. So those type of problems can be, could be because of the one pack is not working, the other pack is not working, or maybe, or this one pack is not working, or this pump is not working. So all these ports can give the information. But the stall test is the test which will help us know why the total power type missing is there, which I mentioned just now as a last. That means you are getting a feeling that there is not much power in the truck when you are moving. At that time, what we should do? So know which element of transmission is possibly defective. It is a good idea to conduct a stall test. It is recommended that the stall test is done in presence of a forklift senior engineer only, a person who has good knowledge of safety to be done while testing. So it is an important recommendation. Why stall test? To know which component is responsible for failure of transmission like sluggish movement, loss of power, loss of acceleration. It does not include cases where it is very clearly known that a specific pack is identified by elimination. We just discussed that you could put a pressure gauge and know whether forward pack is not having enough pressure. So it's clearly known. But if you're having a general feeling of low power, what we should do? This is where stall test is required. Check the engine governed speed. Now, first of all, what we should do is that before starting the test, it is first better to know whether the engine itself is okay or its governed speed is okay or not. It means The engine normally, let's say, example, the fly speed of the engine is 2,300 and governed speed is 2,100 RPM. So when you're checking the full power of the engine, it should run at 2,100 RPM, and the maximum power is experienced. So as an acid test, it is recommended that you take the forks, use the tilting arrangement, tilting circuit, raise the engine completely, and do full back tilt and raise the engine. At that time, with the tachometer, check the engine speed. The speed of the engine should drop down to 2,100, whichever is the governed speed of the engine. If that time the engine speed draws down, that means do full back tilt and still raise the engine. Of course, this type of engine, the tests have been done very for a short time. Cannot do it for 1 hour. It's only 10-15 seconds maximum. But your tachometer will show you whether the engine speed has gone down to say 1,800 RPM or lower than that, which means that engine governed speed is not okay. So by using the governor adjustment or whatever required for raising the engine governed speed, again with the help of the proper qualified person, you can raise the engine speed, engine governed speed. In spite of that, if you continue to have the similar problem, which if they are first experiencing, that is the loss of power, loss of acceleration, then you go to the actual stall test. That is forklift with load. You take it to a wall in the reverse direction. That means you take the fork with full load, that is 3-ton truck with full load on the forks, you take it against a wall and hold the counterweight against that wall. I mean, push the counterweight against that wall and then keep the forklift in reverse only and raise the engine. Now use the tachometer for seeing what is the speed when engine has reached whatever best raving speed is available. So the engine speed is not going to show the governed speed because it is being now stalled. And who is stalling it? It's the torque converter. The torque converter has created a resistance trying to build up that extra torque on the impeller, but it's not being allowed to move because of the static inertia. At that point of time, what is the speed of the engine? What we would expect as the manufacturer and what as what is recommended, it should drop down to the maximum torque speed of the engine. If your governed speed of the engine for maximum power is at 2,100 RPM, the maximum torque speed is at 1,450 RPM. So this speed, the stall torque speed and a stall speed should be close to that. Is it that? Engine raised to full speed with reverse engage, check stall speed with the tachometer, not more than 30 seconds. What happens? Acceptable stall speed is 1,400 RPM. Shows that torque converter is working and engine also is working because engine is also trying to exert that torque, and engine speed has dropped to 1,400 RPM, which is a maximum torque, which is a design speed, and torque converter is seen to be working properly. If the stall speed drops to 1,000 to 1,200 RPM, it means engine has lost its power. Though we saw with the maximum tilting, we thought that we are okay, but then now it's giving an indication that the speed has dropped down more than it is expected to. So the engine could be a problem. If the speed drops down to 650 to 700 RPM, it's a short reason that the stator of the torque converter has failed. That means the stator is not creating that type of torque multiplication, and it's just causing dropping of the engine speed to with the sort of almost to the point of stopping the engine, to the almost like an idling speed. If the stall speed increases beyond the 15 to 600 mark, that means your stall speed supposed to be 1400, it goes higher. It surely shows that the engine is not meeting the resistance it's supposed to meet. It means that somewhere down the line some clutch has failed, but we have not been able to recognize that. So if the engine speed increases, it means there is a clutch failure, or sometimes it is the impeller or turbine failure, some mechanical failure there. So this is a type of test which helps know further, give further information about the uh, problem in the truck. Now we come to some related problems with the transmission. Why do transmissions fail? The most common reason for failure is poor preventive maintenance. That means uh, replacement of filter not being done on time, or the transmission oil is not replaced as recommended. I have to say here that depending on the type of uh, environment the forklift running, it is better to replace the filter and oil more frequently in such areas where there's a lot of dust. But it is not just the external dust and which is causing the problem. One has to realize that oil, dirt can be not it can be dust going inside one part, but there are so many mechanical components in the transmission, as we just saw the oil pump, which is an aluminum body pump with steel type of gears inside. So the aluminum uh, body wears in a legal way also. That means over a period of time it keeps on wearing out, and some of its material will go into the oil, and it will keep on recirculating if the replacement of oil doesn't take place. In addition to this oil pump, we have number of piston rings. Some piston rings are used in the clutch pack. Whether when we discussed about the clutch operation, we saw that the piston is moving to and fro. So it's got on the outside and the inside of the pistons there are piston rings. So those are metal cast iron piston rings which are running on their bores, and those have to be those are also create a wearing out over a period. Also on the shafts of the input shaft and the pinion shaft or output shaft, there are piston rings which are running on shafts which are running at 2000 rpm, and those piston rings are also expected to wear over a period. So their wear also is in the form of some dust which goes into the oil, and we have to remember that this oil, if replaced, will give only a better life. We are knowing customers who have been doing this well and could get life of even 6,000 hours of running time, and that's a very good life coming out from before the first overall. The second aspect of second reason failures take place is unconventional forklift operation. Now, unconventional forklift operation is can be always debated. Anyway, I'm putting forward my observations, and I want to recommend them as, or rather, label them as unconventional operation. Unconventional operations are seen when you are loading the Punjab lorries. When you're loading the lorries which are covered from top, and we want to put the first pallet close to the operator, what does one do? They lift the load, put on the flooring, they lift the second load and push the first load forward. They take the third load and push the first load still forward. That is how we load it. So what operation are we doing? Is that a standard operation of a forklift? No, but it is being done because of that's the best equipment available for doing this job. But what are we doing? We are actually creating forces for, stalling of the torque converter, and in this way reducing the life of the rocket. We are also causing slippage of the forward and reverse clutch packs when they are not when the load, the pallet refuses to move, because we have seen the beauty of the flooring of the Punjab lorries which are used, and from that we can see how much resistance some of the pallets were giving for the movement of the pallets. Second problem of unconventional operation, I've always been objecting, and whenever I went to the customers, I kept on mentioning this to them, that this can be avoided. That is, keeping the forklift. Always keep the forklift in neutral while lifting the loads. But are they doing that? When we go to a point of stacking with the diesel forklift, what we would do normally is take the truck in full gear and go up to the point of stacking, just push the brake down and do the lifting. Inadvertently keeping the forward gear in engagement and raising the engine fully to get your lifting speed. That means you are braking the truck. You want to move. You don't want to put the truck in neutral. You want the truck to be kept in forward. Then press the press the brake pedal to see that it doesn't move. So you're creating a high stall torque condition here. You're also giving a bad situation for you for lifting, because now the engine speed will drop down to the stall speed. So you'll not get your full lifting speed. So they are not only creating a problem of torque converter failure, they're creating a problem for brake failure, and this way you're not getting your full lifting speed also. So these unconventional forklift operations could be avoided if it's properly recommended and followed. फैन बंद करना, जरा ठंडी ज़्यादा लगता है. And now we come to the very interesting point of fluid coupling transmission forklift compared with the torque converter transmission forklift. The fluid coupling sliding gearbox type of arrangement has some good advantages. That is, it's got a smooth pickup. The torque converter type of forklift also has a very good and smooth pickup. In addition, it's got a better response also, and better. So the acceleration is better in the case of a torque converter type power shift transmission. It is safe to operate during stacking. Fluid coupling transmission or gearbox safe to operate during stacking. Similarly, the torque converter transmission also safe to operate during stacking. The changing of direction involves clutch operation and clutching off. So here here the comfort level of the operator in the fluid coupling truck is quite a challengeable, and it's a problem, and operators would have to actually every time changing the direction, he has to press the clutch, and operate the um, very high effort type operation of the levers. Whereas in the this type torque converter and Powersheet gearbox, it is much more simpler. Um, and the efforts for operation of the forward and reverse and high low is very low. And sometimes it is also possible to have electric shifting arrangement in the power shift type of gearbox. So what we saw there as forward reverse spools we saw in the circuit, that can be now used with the electrically operated valves. Many of the foreign trucks are having this type of arrangement. Fluid coupling and sliding mesh gearbox arrangement normally actually have a lesser complex members, um, so we can call it a very rugged design, and can be used for rough usage like docks, container terminals, long haulage type application. Whereas torque motor type transmissions can be used better in warehouses and similar work environment. Also for container stuffing operation where the containers are on trailers. Fluid coupling and sliding gearbox, I must admit, have low cost of ownership due to the simplicity of design. And as far as torque converter is concerned, the cost of ownership depends greatly on good maintenance practices due to complex hydraulics, and depends greatly on how we operate the forklift. So with this, I am coming to the end of this presentation. I wish to thank Abhishek Chaturvedi for giving me this opportunity to make the presentation. I also wish to thank all of you for being patient enough to listen to this presentation. I'm sorry about the break which happened for some time. Um, Now I'm open to questions.
So thank you so much, Vijay sir, for giving a very detailed presentation. I think it covered all the aspects of transmission systems in absolute detail. And I think this will be a very, very good training manual also for people who would like to understand this system in absolute detail. So, since we have overshot the time by a big amount, we would take only maybe couple of questions in this forum, and we'll close the event. And all other questions we will go back to the audience separately after taking consultation from you, how to reply to those questions. Uh, the first question that I would like to take is that see there is a technology upgradation which is happening in every field. Uh, for example, in a battery also, we are talking about various technologies coming in, like from lead acid to lithium ion, and this way there is a continuous upgradation which is happening in every field. So, what is the future of transmission system? Is it going to change, or is it likely to remain what it is for some time to come? What are your views on that?
Yeah, I mean, just like the torque converter transmission, which we just talked about, in the torque converter transmission itself, we have seen changes taking place, that transmission and axle used to be integrated as a trans axle earlier. Um, but the changes have been seen in the recent past, that the transmission and axle have been separated and connected with a universal joint. That is one change I've seen. The reason being that somehow by separating the transmission and axle, it's possible to have some better results in vibration and other things. Probably um, also it is easier to change to different type of models by changing the axles with the same transmission. This type of changes are possible. Also, these type of new transmissions are coming with electric shift, which uh, would also be a good change and further reduce the efforts of the operator. Where today we are using finger point control, uh, finger point control, um, and so it's the electro-hydraulic system which we are talking about. That means the clutch packs are operated hydraulically, but the operations are done with the electrical actuation. So this type of changes technically is what in the existing type of systems, power shift transmissions. But we have seen dual clutch type of transmissions also coming in cars. I don't know why they are not being introduced today in the forklifts. The dual clutch systems don't have torque converter. They're having various speeds operated by separate clutches. Those are quite common now. So they are competing with the torque converter transmission. For example, Fortuner is having a torque converter transmission, but the Endeavour is having dual clutch system. So people are made to make choices between torque converter transmissions and dual clutch systems. At the same time, for a long time, companies like Linde and now Kion has have had started with the hydrostatic transmissions, where they are using variable displacement pumps and motors for giving the drive. So this is also one uh, area where different type of transmission has evolved. They have been there for some time, but they somehow, because of the very high cost of the pumps and variable displacement pumps, and they are not been indigenous so well, so they are uh, not been adapted into our systems. So I hope this answers the question.
Yeah, I think comprehensively, and it's really very encouraging and good to know that these sort of things are happening even in transmission systems, and there's continuous evolution happening even in this field. Uh, so the next and the last question that we would like to take for this session is, though there are many more, why does a fluid coupling forklift need a clutch? Since in automatic transmission also there is use of hydraulics in clutch pack. Why can't fluid coupling be used to shift the gear without clutch? And what
Yeah.
is the exact need of clutch in a fluid coupling?
So as I
And there's
said,
no need in automatic. And there's no need in automatic. So that's the full question actually.
yeah. So I think I had covered it, and I think it must have gone out during that blank period probably. What I was telling was the fluid coupling has come into the system mainly to give that smoothness in drive. The fluid coupling is capable of disconnecting the drive, but not if the downstream item is a sliding mesh gearbox involving clashing of sliding mesh gears, or even if it is a constant mesh gearbox, sliding of the sleeve and dog teeth arrangement, which is used on constant mesh gearboxes. So there the rotation of the input shaft is not allowed for making the changing of the gears. But while having said that, I mentioned, I don't know whether it was caught up in the discussion, that in the BST, when I was having my training in BST years ago, I've seen the gearboxes which are known as epicyclic gearboxes. They were used on the Tata and Leyland buses of those times. Earlier, the Daimler buses, they were using epicyclic gearboxes only with fluid coupling. And it is possible to have only fluid coupling and a gearbox without clutch. if the downstream item is not a clashing type of gear. So because the clashing is there of the gears, you have to completely disengage the drive. So this fluid coupling is not able to do. So you are using the fluid coupling only for getting the advantage that once you have changed the direction or changed the speed, you just release the clutch pedal, but still the truck will not move. And then you slowly accelerate and you use the fluid coupling for that. So
Okay.
that's
So
why. So it's not that you cannot use. In fact, the question would have been very good. Like with the Powershift gearbox, if you are using only the torque motor. So with the Powershift gearbox, can we use the fluid coupling? I said yes. I can say yes. No one has tried that, but the torque motor gives you the extra torque for breaking the static inertia, which fluid coupling will not give. But even then, you could still use a Powershift gearbox along with the fluid coupling.
right. I think that's very well explained. So we are completely out of time, sir. So even though we would have liked to continue this session with many interesting questions coming in, but due to paucity of time, we have to close the event now. Taking this opportunity to thank you for this wonderful session, which,
Thank
as
you.
I mentioned earlier, is really covering. It's really like a now a ready-made manual for anybody who wants to know about transmission systems. And before everybody signs off, requesting everyone to please put their feedback on the link that we have shared in the chat box. It will really help us to understand your feedback on this session, and do let us know if you would like us to cover any particular topic in forthcoming sessions. So, with that, I thank all the audience who have taken time out from their busy schedule to attend this session, and hope to see you again in our next webinar in February. With that, thank you so much, and we end the event at this point. Thank you.
Thank you.